Guys, today we're going to talk about something brand new, and that's called a conic section. And so, what a conic section is simply taking two cones, and we're going to stack them on top of each other, and then we're going to take a plane, which is basically like a sheet of paper, and then we're going to cut through the cones with our piece of paper. So I have two different visual aids right now. One of them is actually running and showing you what's happening as that piece of paper is slicing through those cones. And so this one you can see as it's going through both the cones, it's making a hyperbola, which looks like two parabolas together. Then it starts turning into just a parabola when it's only touching one cone. Then an ellipse, which is like an oval. And then eventually, once it gets to that, whoa, and then it turns into a circle. So if I look at this picture, we can kind of see that too. We have our hyperbola when it's cutting through both cones. Then we have the parabola going through one cone, the circle when it's exactly parallel to a base, and the ellipse when it's not parallel to the base. So here's in our foldable, we have a little bit of another picture, which I think is a little bit easier to see because it's only one per cone, per set of cones, I guess. So if we're trying to make a circle, we are going to cut my cone parallel to the base. So when I say parallel to the base, I mean this is a base of my circle or my cone, and that's how I'm going to cut with that plane. Okay, a hyperbola, we're going to be perpendicular to a base because when I'm perpendicular to that base, you're going to see I make those double parabolas, and that's what a hyperbola is basically. An ellipse, you're going to have to cut your cones at an angle, but you can't go through the base because if you go through the base, then you're going to make a parabola. So again, this is kind of an idea of how you would cut those cones in order to make each of these shapes. So we're going to start kind of basic. We're going to start with our circle first. Okay, so a circle, you've probably seen this before, just kind of reviewing a little bit because this goes along with our conic section, but a circle is just the set of all the points that are a distance, an equal distance away from another point. Basically, you have a center and all of the points are the same distance away, or the radius. So when I look at this equation is the standard form of a circle. And there's some special parts in here. First of all, my center of my circle is going to be denoted by h comma k, and we've seen that with parabolas a lot, but my center is always the x coordinates, always with the x, the y coordinates always with the y, and then it's going to be opposite sign of what you think because of these minuses. Okay, and our radius in this is going to be r. So if you look in this equation, there's a squared right here. So with that squared, no, that means I'm going to have to take the square root in order to find the radius. So let's do an example question. This equation is an equation of a circle. So they could ask me a lot of stuff about it. I'm going to find some pieces about it and then graph it. So first of all, the center of this circle is again h comma k. So since this is a plus sign, that means that my sign flips. So my center is actually at -3 and then just +1. So it switches the signs on the inside there. My radius is, remember, this is r squared. So I'm going to take the square root of 81, and that's just 9. So when I graph this, and this is going to be great because I totally had a grid drawn and everything just ready for it. Okay, I'm going to plot my my center, 3, 1, and then I'm going to graph the radius. Now remember, it's 9 away on every single side. So I'm going to go up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to go to the left 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Go down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then over, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to try to connect the dots. Obviously mine is looking a little bit not circular, but they all are technically 9 away. Okay, so again, I won't judge the circularness of your circles, because I obviously didn't do too well on that. Okay, so let's do a couple more examples. This is probably the most tricky kind of example you're going to see. It says write the equation of a circle that has the diameter endpoints at those 2 points. So we don't know the center, and we also don't know what the radius is. We only know where 2 points on my circle are that are directly across from one another. So there's going to be 2 formulas that we need to know for this. The first one is so we can find the center, and that's the midpoint. Midpoint is really basic. You're basically taking your two x values of your coordinates and you're finding the average of them. So we're going to add the x coordinates, divide by 2. Same deal with the y's. And that's going to find me my center. Okay, so to find my center here, again, I can just label my points, x1, y1, x2, y2. And I'm going to have 3 plus negative 5, or 3 minus 5 over 2. And then I'm going to have 6 plus 2 over 2. Okay, that gets me the center, or the middle of both of those points, as negative 1, 4. Okay, again, directly in the middle of your diameter should be your center of your circle. So we're going to need this piece of information when we're writing my equation. Okay, the next thing we need to figure out is the radius, how to find the radius. Well, all I have are 2 points, so I'm going to have to use my distance formula in order to figure out how long is this segment. And so the distance formula is the one that's all underneath the square root. So it'd be x2 minus x1 squared plus y2 minus y1 squared. And then you take the square root of that. Okay, this is just distance formula you probably talked about in geometry, I assume. So if we plug in our points, we will have x2, so negative 5, minus 3 squared plus y2 minus y1 squared. All that's going to do is get rid of my negatives, thank goodness, because I can't take the square root of a negative. That gets me negative 8 squared is 64. Remember, no more negatives. Negative 4 squared is 16. Okay, and so that ends up getting me the square root of 80. So this is the diameter of my circle. Diameter. Oh no, I ran out of space. Which would then mean that my radius, I just have to divide by 2. So my radius then is just the square root of 80 divided by 2. And I could simplify that out. I know that the square root of 80 is going to be equivalent to 4 root 5. I'm actually going to leave it alone though, because I know for my equation, I'm going to need to do r squared. So when I finally plug in all the information that I know, I'm going to have x, remember it's minus a negative, so we'd have plus y minus 4, because that was my center. And then I need to find r squared. So I'm going to go ahead and take square root of 80 over 2 squared. Now when you square a square root, that goes away. So I'm left with 80 over 4, and 80 over 4 is equivalent to 20. So you could either write it as the square root of 80 over 2 squared, or you could just write that as 20. Okay, and so that's how you'd figure this one out. You need 2 different formulas, and then you have to plug it into your circles equation. Okay, now what if they give you a picture instead of words? So I'm looking at this picture and I want to find an equation. So when I'm finding the equation here, my first goal is to find the center of the circle. So I know that that center should be about here. And if you think about it, that center is going to share the y coordinate of this side point, and it's going to share the x coordinate of the top point, which makes that center negative 2, negative 3. So when I plug it into my equation, again, you have to be careful of your sign. I'm going to have x minus a negative 2, and then I'm going to have y minus a negative 3. And now I've got to find my radius. So when I'm looking for my radius here, I'm thinking about how far away is any point on the outside from my center. Well, I can see that that is just going to be 1 away. And if I went from side to side, I'd also see that that's just 1 away. So I'd have 1 squared, or just 1. So my equation would just be x plus 2 squared plus y plus 3 squared equals to 1. Okay, so again, you've got to find your center, and then you've got to find your radius, and then you just write your equation. Now, here's the most scary part about this whole conics thing, and that is to remember how to complete the square. I have to complete the square in order to get my conics equation into standard form. This is technically a conic section, but I can't do anything with it because I don't know what's going on at the moment. So whenever I see something like this, I'm going to complete the square, and I'm going to have to do it twice because there's 2 squareds inside it. So my first goal is I'm going to get any of my constants to the other side. So I'm going to go ahead and subtract 45, and then I'm going to rearrange my equation so x's are together and y's are together. So this is going to have x squared minus 10x, and I'm going to leave a space because I know I'm going to end up needing to add something in here, plus y squared minus 12y plus, I'm not sure yet, and then I move my 45 over by subtracting 45 from both sides. Okay, so now when I'm completing the square here, I'm trying to think about how I could make this into a perfect square binomial. So that way I only have x plus something or x minus something quantity squared. And in order to figure that out, you're always going to take your b value and divide it by 2. So I'm going to take negative 10 divided by 2 and then square it. So in this case, that gets me negative 10 over 2. And I'm going to square that, which is negative 5 squared, which I know is positive 25. So I'm going to add 25 in this blank. However, if you add something to one side of the equation, you can't just change the value of the one side. You've got to go ahead and add that same value to the other side. Okay, so we're going to do that again for the y's. Again, you're going to take your b value, divide by 2, and square it. So that gets you negative 6 squared, which is positive 36. And again, I've got to add it to both sides in order for me to leave my equation alone. Okay, so now I'm looking at this and I'm going to factor what's in the parentheses. This is again supposed to be a perfect square. So I'm thinking about my factors of positive 25 that add up to negative 10. Well, that would be negative 5 and 5. Okay, again, my factors of positive 36 that add up to negative 12, that would be negative 6 and 6. So you notice these two actually come into play later when you're actually factoring. Then I'm just going to add up those things on the other side. That gets me 16. And now this is standard form of my circle. I could find stuff out about it. I would know that this circle has a center at 5, 6, and it has a radius of square root of 16 or 4. So dig out that completing the square stuff you did in Algebra 2 because we will have to complete the square in order to get our conics into standard form.